Hello and welcome once again to the Akash Byju's J channel. My name is Atiola and we are live with the Rankers Batch 2023. So if you want to be a ranker in J Main and Advanced 2023, then this is the place to be. Alright guys, a very warm welcome. So on agenda today is Laws of Motion. So, we are going to start a new chapter today, Newton's Laws of Motion. And I don't need to tell you how important this chapter is. This is such a fundamental chapter, such an important chapter that every chapter after this is going to use Newton's Laws of Motion. And we are going to take up a very interesting and important topic, and a topic in which a lot of students face difficulty, which is the constrained motion. So we are going to go in depth, in detail with string and wedge constraints so that you don't have any problem in this topic. And some very beautiful, some very nice questions are framed on this topic, and it is frequently asked in all competitive examinations. Alright guys, so if you're ready for this session, if you're pumped up, quickly give me a thumbs up, quickly give me a yes. Miss Queen is here. Hi Miss Queen, how are you? All set for the session? So quickly give me a thumbs up and we will get rolling with this session. Okay, very important session because these concepts are used everywhere. Wherever you have to apply Newton's laws of motion, you have to know these concepts. Alright, all set, all good, perfect. Chalo, so let's get started with this session. Now before that, important announcement, you would have heard of Anthe. So if you know anyone from class 7 to 12th, do tell them about Anthe. And if people do well in this examination, there are a lot of rewards that can be won, as you can see on the screen. Alright, chalo, let's get started. So Miss Queen is asking, sir, can you explain the full chapter? Yes, Miss Queen, we are going to do the entire chapter. So this is the first lecture of Newton's laws of motion. We are going to cover the entire chapter. We have already covered kinematics completely. We have done everything on kinematics, and we are going to do the entire syllabus in these sessions. Alright, so you are going to get everything over here, and not just this, you're going to get the DPPs, you're going to get chapter tests, so you don't have to worry about anything. All you have to do is subscribe to this channel so you don't miss the classes, and just attend these classes in a regular fashion. These are live classes, so you can ask doubts as well. So Miss Queen is saying, okay sir, thank you, I face many problems in this chapter. I know this topic especially is something which not a lot of people are comfortable with. It's a very, very conceptual topic. So we are going to go in depth, in detail, and I assure you that after this session, you're not going to face a lot of difficulty. But that is when you pay attention over here, and you are here with me with your notebook and pen, and you are here with me solving all the questions together, making your own notes. So that is going to be very helpful for you. Okay, and if you feel that we are adding value to your preparation in any way, do give us a like, do share it with your friends, and that is going to mean a lot to us. Alright, chalo, let's get started with this session, and we are talking about string constraint. Okay, Sapna is also here. Hello Sapna, how are you? Chalo, let's get started. We are talking about string constraint. And what is the constraint here? Constraint means there is a restriction. There is some kind of restriction that we are applying in the motion. What does it mean? Now for string constraint, we assume that the string is inextensible, meaning the length of the string cannot be changed, and you can apply this to a rod as well, because for a rigid rod, the length of the rod cannot change. Okay, so what is the assumption over here? The string is inextensible, the length of the string cannot change. Is that right? Alright. Now, if the string has mass or it does not have mass, is going to have a different consequence. We are also going to discuss that. But right now, the only assumption here is that the length of the string is a constant. Alright, so what is the repercussion? What is the inference we can draw from it? So there are 2 points, A and B, or there are 2 objects. We are connected to this string. Okay. Now, let's say A moves by a distance xa, and B moves by a distance xb, and these displacements are along the length of the string. Now, what is B trying to do? What is this xb trying to do? Forget about xa right now. Just think about what is xb trying to do. xb is a displacement which is away from the center of the string. So it is trying to increase the length of the string. And by what amount it is going to increase the length of the string? It is going to increase the length of the string by an amount xb. So what is delta L, or I should write delta x? Delta x is the change in the length of the string. Okay, it is the change in the length of the string. So xb will try to increase the length of the string, because you can see that xb is a displacement which is away from the center of the string. Now what is xa trying to do? xa is a displacement which is towards the center of the string. Is that right? It is towards the center of the string, which means it is trying to decrease the length of the string. So what is the change in the length of the string because of xa? It is minus xa. Is that right? And what we know is that the length of the string cannot change, so this should be equal to 0. Which means what do we get? We get xa is equal to xb, va is equal to vb, and if we differentiate it again, we are going to get the acceleration of a is equal to acceleration of b. Swastika is here. Good afternoon, Swastika. New and important chapters started indeed, Swastika, and especially this topic is something that we use. Now, before even telling you string constraint, you know that xa will be equal to xb. But a lot of times the actual concept is not clear. So in complicated situations, you face problems. So I'm going to resolve all that problem. All right, so now here we are sorted. Whatever will be the relationship between the displacements, the same relationship is going to exist with the velocity, and the same relationship is going to exist with the acceleration. All right, let's go further. Now let's say that the displacements are not happening along the length of the string. Let's say this displacement is xa like this, and this angle is theta a. And let's say this displacement is happening like this, xb, and this angle is theta b. Now in this case, we are still going to say the same thing. What is the change in the length of the string? Now, what we have to do in this case is, we'll have to take the components of the displacements along the string. Because the displacement is xb. But what is the amount of change in the length of the string it is bringing? It is only bringing a change of xb cos theta b. Do you agree? And what is the displacement of this particle in the direction of the length of the string? It is xa cos theta a. And so we can say that xb cos theta b is trying to increase the length of the string because it is away from the center of the string, and xa cos theta a is trying to reduce the length of the string. So we're going to write the change as minus xa cos theta a, and we know this is going to be equal to 0, which means xb cos theta b should be equal to xa cos theta a. And if we differentiate it once, we are going to get vb cos theta b equal to va cos theta a. And if we differentiate it again, we are going to get ab cos theta b is equal to aa cos theta a. Is that correct? Is this clear? Is this basic concept absolutely clear? So the velocities, we have to take the component along the length of the string, because that component is the change it is trying to bring in the length of the string. Is that right? Is it clear? All right, so let's quickly solve a question on this topic. This is the concept check post. It is a very famous question. It is a very popular question. You would have seen this question everywhere, in every book, in every textbook. This question is going to be there, okay? But a lot of times what we do is we use different methods to solve this question. There are many methods to solve this question, but we are going to look at the easiest, the simplest method, which involves the constraint of length. Okay, the one way of solving this question is that you can assume this distance to be y, and you can assume this distance to be x. Okay, you understand the situation? There's a rod, one end is on the floor, the other end is on a wall, and this rod is slipping. So obviously point B is going to have a velocity of Vb along the wall, and point A is going to have a velocity along the floor, and its velocity is Va, and this particular instant this angle is theta. Okay, now one way of doing it is that if you choose x and y like this, you can say that x square plus y square, should be equal to L square. Simple Pythagoras theorem. Okay, x square plus y square should be equal to L square. Now what we do is we differentiate on both sides and we say this is 2x dx by dt plus 2y dy by dt. And if we differentiate length with respect to time, what is it going to give us? It is going to give us 0 because the length of the rod does not change. Okay, so this 2 and this 2 is gone. So what do we get? We get x multiplied by, what is dx by dt? It is the rate at which this distance is changing. Okay, it is the rate at which this distance is changing. So what is this going to be? This is going to be the velocity of A. Do you agree? Is that correct? This is going to be the velocity of A plus y multiplied by dy by dt. What is dy by dt? dy by dt is the rate at which this length is changing. Okay, and what is that rate? That is simply the velocity. So what we are going to do is we are going to substitute minus vb. Be careful about this. We are going to substitute minus vb because the rate of change of y is negative, right? As the rod is slipping, this length y is decreasing. That is why what I have done is I have substituted minus vb. Is that correct? So what is va going to be equal to? Va will be equal to y by x multiplied by vb. Is that correct? And what is y by x? Can you tell me what is y by x? This is y, this is x. So can I say y by x is equal to tan theta? Of course I can say that. So we can say that VA is equal to tan theta multiplied by VB, and that is the relationship between VA and VB. Is that correct? Yes, Sapna, you are absolutely right. VB will be equal to VA cot theta. Now this is one way of solving the question, but we have learned constraint. So why not use it? है ना? जो सीखा है उसको अगर यूज ही नहीं किया तो सीखने का फायदा क्या? चलो, let's try to use that concept. All right. So we can see that this angle is going to be theta. Do you agree? Obviously that angle is going to be theta. And can you also see that this angle is going to be 90 minus theta? So this angle is going to be theta. Is that correct? Is that right? Okay. Now we know that the length of this rod is not going to change. So what is the velocity of this end? What is the velocity of this end which is along the length? This velocity is going to be VA cos theta. And what is the component of this velocity along the length? It is VB sin theta. What is this? This is VB sin theta. Now we only have to concentrate on the component of the displacement, velocity or acceleration along the length. You can forget about everything else, right? So what can we say? This VA cos theta is away from the center of the string, okay? Which means that it is trying to increase the length of the string. And this VB sin theta is towards the center of the rod, which means it is trying to decrease the length of the rod. So this is going to be minus VB sin theta, and this should be equal to 0 because the length of the rod is not going to change in any circumstances. So we get VA is equal to tan theta multiplied by VB. Is that correct? So using this, you can solve this problem in a jiffy, right? So instead of writing the Pythagoras theorem, differentiating and solving this in 4 steps, we can solve it in 1 step. That is the power of this concept. Is this clear? Is this absolutely clear? If it is clear, quickly give me a thumbs up. Quickly give me a yes so that I know you understand this very well. This is very important to your understanding. Okay? इसको रटना नहीं है, ठीक है? रटोगे तो डिफिकल्ट क्वेश्चन जब आएगा, कॉम्प्लिकेटेड क्वेश्चन आएगा, तो वहां पे आपकी हवा निकल जाएगी, ठीक है? तो रटना नहीं है, इस कॉन्सेप्ट को डीपली समझना है. सो इफ यू हैव अंडरस्टूड दिस कॉन्सेप्ट, तो फटाफट गिव मी अ यस, गिव मी अ थम्स अप, लाइक दिस वीडियो सो दैट वी कैन मूव फॉरवर्ड. चलो, क्लियर है? तो आगे बढ़ते हैं. नाउ we take this string which is inextensible and we put it on a pulley. ठीक है? पुली ब्लॉक प्रॉब्लम तो हमने कितने सारे देखे हैं. So many pulley block problems you would have seen in the course of your study. Let's try to understand and get to the bottom of this, get to the depth of this. ठीक है, सिर्फ ऊपर ऊपर से नहीं देखना है, बिल्कुल डेप्थ में जाके समझना है एक एक छोटी छोटी चीज, बिकॉज दैट स्मॉल थिंग कैन कॉज एन एरर इफ द एग्जामिनर इज स्मार्ट एंड द एग्जामिनर ट्राइज टू ट्रैप यू. ठीक है, तो एक छोटी छोटी चीज भी अपने को समझना है. चलो, तो पुली कुड बी ऑफ टू टाइप्स. वन इज अ फिक्स्ड पुली. फिक्स्ड पुली मतलब इट इज नॉट गोइंग टू मूव, समथिंग लाइक दिस. And then there could be a movable pulley like this. For example, if you move this end up, the pulley is also going to move up. ठीक है? Is this correct? Is this clear? So there could be two kinds of pulleys, a fixed pulley and a movable pulley. And दोनों में the treatment of the constraint relationship is थोड़ा सा different. ठीक है? But let's try to understand it. First, let's talk about a fixed pulley. ठीक है, I'm taking the simplest example. आपको भी पता है इसका आंसर क्या है, आंख बंद करके आप मुझे बता दोगे इसका आंसर क्या है. But that's not the point. The point is to understand the concept. चलो, let's begin. So what I'm going to tell you is, and you can note this down. The first thing is, the points which are attached, the points which are in contact with the fixed pulley are assumed to be fixed. ये लिख लो. You can write this down. ठीक है, और I'm writing it here. Points attached to the fixed pulley are considered fixed. Is that right? So this point over here and this point over here, I'm going to assume they are fixed. Are they actually fixed? No, of course not. They are not fixed. ठीक है? But the calculation is such that if we make such an assumption, हमारा result सही आएगा. ठीक है? So I'm teaching you how to apply constraint of string on a fixed pulley. So what we are going to assume is that these 2 points which are attached to the string is, these 2 points which are attached to the pulley, ठीक है, which are attached to a fixed pulley are going to be fixed. They are not going to move. ठीक है? Now let's assume that this point which is connected to mass m2, this displaces down. This is displaced down by a distance of x2. And this point, I know that it is going to move up, but even if I'm a dumb person, I can assume that it is going down and nothing is going to make a difference. ठीक है? Let's say I'm a dumb person. ठीक है? Maybe I'm a dumb person. I'm assuming that the displacement of m1 is down. ठीक है, I know that the displacement of m1 is going to be up, but I'm a dumb person. I'm assuming that it is going to go down. ठीक है, स्वास्तिका बोल रही है, it means when the string moves over the pulley, it does not make any angle, it goes straight up or straight down. नहीं स्वास्तिका, उसकी बात नहीं है. बात ये है कि this length of the string, which is over the pulley, this is always going to be constant. ठीक है, this length of the string which is over the pulley is always going to be a constant. ठीक है, which means change कहां पे आ रहा है? change आ रहा है इस segment में और change आ रहा है इस segment में, right? So that is why we assume that वो जो length है pulley के ऊपर वो तो same ही रहेगा, तो उसका टेंशन ही क्यों लेना, right? So we assume that the points which are attached or which are in contact with a fixed pulley are going to be fixed, and you will see that इसका result क्या होगा. ठीक है? Alright, now this is how I have assumed the displacements. You can assume the displacement differently. This is how I have assumed the difference, and I assure you we are still going to get the right answer. ठीक है? So now what do we have? We have two segments. We have segment 1 and we have segment 2. We have two segments of the string. Now remember this very clearly, that the length of individual segments can change. अभी x2 नीचे जाएगा तो राइट साइड वाला जो स्ट्रिंग है उसका लेंथ तो इंक्रीज होगा. अब ये m1 जो ऊपर जाएगा तो लेफ्ट साइड वाला जो है उसका डिस्प्लेसमेंट कम होगा, उसका जो लेंथ होगा वो कम होगा. सो द लेंथ्स ऑफ द इंडिविजुअल सेगमेंट्स कैन चेंज, but can the length of the entire string change? No, the length of the entire string cannot change. So what we are going to do is we are going to write the change in length segment by segment, correct? So I'm going to say, okay, let's start. Let's talk about segment 1. The change in length due to segment 1. Now because of this point, the displacement is x2 away from the center of the string. It is away from the center of the string. So it is going to increase the length of the string. So I'm going to write plus x2. हाँ कि ना? ये बात clear है? So I'm going to write plus x2. Now what is the other end of the segment? This is the other end of the segment. है कि नहीं? This is the other end of the segment, and I'm going to say that its velocity or its displacement is 0 because it is fixed. It is attached to a fixed pulley. तो ये क्या हो जाएगा? x2 plus 0. What is this? This is the change in the length in the first segment. Do you agree? Change in the length in the first segment. Plus segment का length is equal to 0 नहीं करना है. सेगमेंट का चेंज इन लेंथ इक्वल टू 0 नहीं करना है. पूरे स्ट्रिंग का चेंज इन लेंथ इक्वल टू 0 करना है. सो दिस इज द चेंज इन लेंथ इन द सेगमेंट 1. नाउ आई एम गोइंग टू राइट द चेंज इन लेंथ इन सेगमेंट 2. ठीक है, तो ये पॉइंट क्या है? दिस पॉइंट इज फिक्स्ड. सो बिकॉज ऑफ दिस देयर इज नो चेंज इन द लेंथ. प्लस what is happening? This is going, this x1 is away from the center of the string. This x1 is away from the center of the string. What is it trying to do? It is trying to increase the length of the segment. So I'm going to write plus x1. Is that correct? Now what I have done is I have written the change in the length of the string, the entire change in the length of the string. And this should be equal to 0. So what do I get? I get x1 is equal to minus x2. Even if I was a dumb person, I know that whatever you have taken as x1 is not right. x1 is going to be opposite to x2. So I will say, okay, my mistake, I am dumb, I am going to correct my mistake, and now I know for sure that x1 will have a direction opposite to x2. Yes. Swastika, I don't know if it is called law of conservation of string length. I don't know if there is a law which is called like this, but you understand the concept. The length of the string, it is a consequence of string constraint. ठीक है, ये बात क्लियर है? So no matter what you do, हमने बना लिया ना, ठीक है? चलो ठीक है, agreed. चलो, so my point is whatever you do, you apply the constraint equation correctly, you will always get the correct answer. जिस direction में assume करना है कर लो, no worries. Whatever direction you want to assume, you assume, just apply the equation correctly, you will get the right answer. ठीक है, इसमें कोई तकलीफ? चलो, अब सेम थिंग क्या करते हैं? सेम थिंग हम लगाते हैं मूवेबल पुली पे. लेट्स से हाउ डू वी डील विद मूवेबल पुली. ठीक है, सो फॉर दिस व्हाट इज द इंपॉर्टेंट पॉइंट? पॉइंट्स अटैच्ड टू अ मूवेबल पुली are assumed to move with the same displacement as the pulley. बात समझो, ठीक है? अब यहां पे समझो क्या बात हो रही है. Now this pulley is going to move. So let's say that the displacement of this pulley is y. Okay, so there is this point which is being pulled up, there is this point which is being pulled up. ठीक है, now the pulley is going to move up, so we are going to say that the displacement of the pulley is y. We are assuming that the displacement of pulley is y, and ये तो common sense बताता है कि displacement of m1 क्या होगा? वो भी y होगा. This m1 is attached to the center of the pulley, so the displacement of the pulley will be the same as the displacement of mass m1. ठीक है, so this is also going to be y. Now the most important thing, the points which are attached or which are in contact with the pulley, we will assume that they also have the same displacement. So I'll assume कि इसका displacement भी y है और इसका displacement भी y है, because it is going along with the pulley. Is this clear? Is this statement absolutely clear? This is the critical statement. क्या ये clear है? ठीक है, चलो बहुत बढ़िया. Now what I'm going to say is, let's say कि ये जो point है, this point of the string which is being pulled up, let's say इसका displacement है x. So you know what am I getting at? I'm getting at finding the relationship between x and y. I want to find the relationship between x and y. Is that correct? Oops, something happened to my vacuum. Just a second. Something happened to my Wacom. Okay, it's starting up. Just give me a second. Just give me a second. Yeah, we are back. Chalo. ये बात clear है? Now, how many segments are there? So what I'm saying is that I'm going to say that this string, कौन सा string? This string, the length of this string is not going to change. So how many segments are there in this string? There is one segment over here and there is one segment over here. So I'm going to write the change in length for both the segments. So first I'm writing the change in length for the first segment. Now what is the end? There is x which is away from the center of the string, which means it is going to be plus x. Then there is y. Then there is y which is towards the center of the segment, which means I'm going to write it as minus y. And then we are going to talk about the second segment. Now this point is fixed. It is attached to a fixed support, which means this point is 0. And then this point over here is going towards the center of the segment, which means the displacement it is going to cause is minus y. Now this is the total length. This is the total change in length of the string, and we know that this should be equal to 0. So what do we get? We get x is equal to 2y. आ गया relationship. Alright, Swastika is saying, sir, but left string is attached to ceiling. How can it increase by y? Ceiling नहीं ना बाबा. ये. This is increasing. This is decreasing by y. देखो, the point which is, now this segment, understand this. This segment, let me explain this again. Now this segment has 2 points. This is 1 point. Now this point is attached to the ceiling or a support. So this is not going to cause any change. That is why I have written 0 over here. Correct? Now what about this segment? What about this point of the segment? This is going to have the same displacement as the center of the pulley. So this is going to have a displacement y like this. Okay? So what is this y? This y is towards the center of the segment, which means I'm going to write minus y. So x क्या आ जाएगा? X equal to 2y. Is this clear now? Guys, is this clear? If this is clear, quickly give me a thumbs up. चलो बताओ. Is this clear? Okay, so what we have done is, we have taken 2 segments. We have taken the individual segments. We have written the change in length of the individual segments, added them up and made it equal to 0. That's it. And there is one assumption. Fixed pulley के case में, the points which are attached to the pulley, they are fixed. In case of movable pulley, the points which are attached to the pulley move with the same displacement as the pulley. तो मुझे x और y का रिलेशनशिप समझ में आ गया. x is equal to 2y. अब डिफरेंशिएट करोगे तो कितना हो जाएगा? vx is equal to 2vy. उसके बाद फिर डिफरेंशिएट करोगे तो acceleration of x is equal to 2 times acceleration of y. Okay, so this is how we apply the constraint equation on a movable pulley. Clear है ये बात? ठीक है? How many of you knew this method पहले से? Write it down. If you knew this method पहले से, write it down. Or if this is the first time you are learning this, write it down as well. ठीक है? चलो. Now we are going to solve the same problem, and this method I call it the common sense method. Why common sense method? Because इसमें common sense लगता है. You can either use the constraint or you can Swastika बोल रही है, had it not been fixed to the ceiling, then left could have increased. Yes, Swastika, उस केस में ये left किसी और चीज से attached हो सकता था, तो अपने को देखना पड़ता कि ये किससे attached है. Then we'll have to see कि what is the displacement caused by it. But because it is fixed, it is attached to a fixed support, the length cannot change. ठीक है? चलो. तो अब क्या बात करते हैं? अब बात करते हैं कॉमन सेंस मेथड की. ठीक है? कॉमन सेंस मेथड प्योरली रिक्वायर्स कॉमन सेंस. सो इफ यू डोंट अंडरस्टैंड दिस, यू नो व्हाट आई एम इम्प्लाइंग. ठीक है? चलो. ऑलराइट, लेट्स स्टार्ट. सो व्हाट वी वांट टू डू इज, दिस एंड ऑफ द स्ट्रिंग इज बीइंग पुल्ड. Okay, let's say this end of the string is being pulled, and we have to find the relationship between the displacement of this end of the string and the displacement of mass m1. ठीक है, we have to write this, we have to figure this out, the relationship between the point which is being pulled up, and then we have to find out the relationship between the point which is being pulled up and the displacement of m1. ठीक है, now what I'm going to assume is, let's say that the pulley moves up by a distance of x. The pulley, string को वैसे ही रहने दो, string को पकड़ के रखो, don't move the string, just move the pulley up, just move the pulley up by a distance of x. Now if the pulley is moved by a distance of x, how much thread is going to become free? X from here is going to become free, and x from here is going to become free. Okay, think about it. Keep the thread as it is, keep the string as it is, just move the pulley upwards. ठीक है, imagine कर पा रहे हो, बस pulley को ऊपर move कर दो. Then length x of the thread will become free from this side, and length x of the thread is going to become free from this side. तो अगर आपको ने pulley को x move किया, so this block is also going to move by how much? This block is going to move up by x. Do you agree? If you have moved the pulley up by x, this block is going to move up by x, and the length of the thread which becomes free is going to be x plus x, that is 2x. तो free कितना हुआ? 2x हुआ. अब इस 2x को कौन ले जाएगा? Can this point take this 2x? No, it is a fixed point, it cannot move, so it cannot take it, which means this end is going to move up by 2x. This end is going to move up by 2x. Is that correct? ठीक है? So the relationship between the displacements of this point and this m1 becomes very clear. अगर m1 x ऊपर जाएगा तो ये जो point है, this will move up by 2x. ठीक है? The string cannot become slack. ठीक है? If we are dealing with string, the string cannot become slack. अगर string slack हो गया, then the constraint relationship does not work. Is this clear? So can I say, let's call this what? Let's call this point A, let's call this point B. So can we say that the displacement of point A is equal to twice the displacement of point B? And similarly, can we say that the velocity of point A is twice the velocity of point B? And similarly, can we say that the acceleration of point A is equal to twice the acceleration of point B? Okay, so we have got the same result. अर्पित बोल रहा है हाउ 2x आई एम नॉट अंडरस्टैंडिंग. ठीक है अर्पित, समझो इस चीज को, फिर से देखते हैं. नाउ यू हैव मूव्ड द पुली. ठीक है, तुम्हारा जो स्ट्रिंग है, योर स्ट्रिंग, इट इज एज इट इज, योर स्ट्रिंग इज एज इट इज. ठीक है, नाउ व्हाट यू आर डूइंग इज यू आर जस्ट मूविंग द पुली बाय x. जस्ट टेक द पुली एंड मूव इट बाय x. ठीक है, you have taken the pulley, moved it by x. Now if you have moved the pulley up by x, this block is also going to move by x. This block is attached to the pulley. So if you are moving the pulley x, the block is also going to move up by x. ठीक है? Now when you have made the pulley go up by x, ये जो part of the string है, ये क्या हो जाएगा? ये free हो जाएगा ना, ये loose हो जाएगा. ठीक है? This part of the string will become loose. And what will be the length of that part of the string? The length of that part of the string is going to be x. अगर तुमने पुली को x ऊपर किया तो इधर से x thread free हो जाएगा और इधर से भी x thread free हो जाएगा. So x thread free from the left side, x thread free from the right side. इतना thread free हो गया है. But ultimately the string cannot become slack. So this point, what is the possibility? Either this point can move and make the string taut again, which cannot happen because this point cannot move. So it is obvious that this point is going to move up and make the string taut again. So by how much length should it move? It should move by the amount of length which has become free. तो ये क्या हो जाएगा? ये हो जाएगा 2x. यानी कि B अगर मूव किया x तो A मूव करेगा 2x. That's it. Right? So is this clear? Is this clear? Is this method clear? I call it the common sense method. तो now अब तुम लोग बताओ, common sense है आपके पास कि नहीं है? Alright, Clear? Chalo, if this is clear, quickly give me a thumbs up and then we are going to move forward. Okay? So a lot of times what is going to happen is that in simple situations, constraint equation works best. In simple situation, constraint equation best works. In slightly complicated situations, आपका common sense method works very well. In slightly complicated situations, common sense method works pretty well. But in extreme situations, in extreme difficult situations, there is going to be another method. So I'm going to tell you another method. स्वास्तिका ये वाला method best नहीं है. This is not the best method. The best method is going to come now. ठीक है? This is called the concept of virtual work. ठीक है? This is called the concept of virtual work. Concept of virtual work क्या बोलता है कि in a system, if the string में क्या होता है? String में होता है tension. So in a system where tension is the internal force of the system, the work done by the internal force of the system is going to be equal to 0. ठीक है? So we are going to say that the work done by tension will be equal to 0. इसको कहते हैं concept of virtual work. Okay, let's try to understand this. The work done by tension will be equal to 0. Now your question should be, the work done, only common sense is here. Common sense is not very common, Arpit. It is very uncommon. So if you have it, it's good. Chalo, let's get back here. Now the question is, work done on what? So work done will be on points which are moving and points which have masses. Points which are moving and points which have masses. So we have to calculate the work done by tension only on the points which are moving or the points which have masses attached to them. ठीक है? Which basically are moving. चलो, तो समझो इस चीज को. So यहां पे क्या करना पड़ता है? अपने को टीटी खेलना पड़ता है. Do you know what is टीटी? टीटी पता है किसी को? What is टीटी? Does anyone know? यहां पे what we'll have to do is we'll have to play टीटी. What is टीटी? Do you know? Have you ever played टीटी? Tell me guys. We'll have to play टीटी. ठीक है? चलो, तो टीटी कैसे खेलते हैं? Let's see how to play टीटी. Okay. So what we're going to assume is that on this block M2 there'll be a tension T. ठीक है? On this block M2 there'll be a tension T. On this pulley there is going to be a tension T. Tension. Yes. Tension. Table tennis नहीं. We are not playing table tennis. हम लोग खेल रहे हैं tension. It is also called TT. ठीक है? तो देखो. So on this block M2 there's going to be a tension in the upward direction. On this point on the pulley there's going to be tension in the downward direction. Now here assumption, यहाँ पे assumption ध्यान से note करो. Strings should be massless. Strings should be massless. अगर string massless नहीं होगा, though the tension will not be the same throughout the string. ये बात clear है? If the string is not massless, the tension is not going to be the same throughout the string, and then उस case में this method is not going to work. तो method का limitation भी जानना जरूरी है. So in that case this method is not going to work. तो ये ध्यान में रखना. Alright? चलो. So ये हो गया T. So this is also T. Now this pulley is frictionless and massless. Correct? We are dealing with ideal situations. Now this pulley is also frictionless and massless and it is not moving. तो यहाँ पे भी टेंशन कितना हो जाएगा? यहाँ पे भी टेंशन हो जाएगा T. And because of that, यहाँ पे भी टेंशन कितना हो जाएगा? यहाँ पे भी हो जाएगा टेंशन T. So this is how we play TT. Table tennis नहीं बाबा. We are playing tension. Okay? But tension खेलने से फायदा ये होता है कि आपके दिमाग का टेंशन कम हो जाता है. Okay? So T. Is this clear? ठीक है? ये करने में तो कोई दिक्कत नहीं है. So we can find out whatever is the tension everywhere. Okay. अब now ध्यान से सुनो. Now is this tension and this tension going to do any work? Quickly tell me. The tension which is acting on the pulley, is that going to do any work? it is not going to do any work. Why? Because the pulley is fixed. अगर पुली फिक्स्ड है, उसका कोई डिस्प्लेसमेंट नहीं होगा, देन द टेंशन इज नॉट गोइंग टू डू एनी वर्क. तो वी डोंट नीड टू वरी अबाउट दीज टू टेंशंस. These two tensions are not going to give us any tension. Okay, so just forget about that. So how many tensions are remaining? There is one tension over here and there is one tension over here. Now we are going to assume that mass m2 goes down by a distance x2 and mass m1 goes up by a distance x1. ठीक है, यहां पे yes, Arpit, Anup, you are absolutely right. So mass m2 I'm assuming is going down by x2 and mass m1 is going up by x1. All right. So in that case, now I could have assumed x1 down also, no worries. Okay. Remember, I am a dumb person. I could have assumed x1 going down, but now I've got a little smarter. Okay. So I'm assuming x1 is going up. We assume pulley to be massless if the pulley were moving, then also tension on it is zero now. Yes, Swastika, I'm going to come to that. I'm going to come to that part. Yes, you're absolutely right. ठीक है, चलो. Now can you tell me what is the work done by this tension? What is the work done by this tension? अब work तो थोड़ा बहुत पढ़ा है ना. Now tension T is up, displacement is down. What will be the work done? The work done is going to be minus Tx2. Correct? And then the tension in this case is up and the displacement is also up. So what is the work done? The work done is Tx1. Is that correct? And the work done by tension will be equal to 0. तो यहां से T गया and we get x1 is equal to x2. आई बात समझ में? Is this clear? If this is clear, quickly give me a thumbs up. All right. The things to remember. Anup is saying T1 plus T2 is 0 because x1 and x2 are opposite. No, T1 and T2 are not 0. T1 and T2 are not 0, Anup. The work done by T1 and the work done by T2 is 0. Yes, Prakhar, you are right. The work done by T1 and the work done by T2 is 0. Work done by T1 plus the work done by T2 is 0. ठीक है? T1, T2 is not 0. Tension तो होगा ना? There will be some tension. Alright, so is this clear? Tension is part of a system, work done by internal force is 0. Correct. Is this clear? Is this absolutely clear? So now let's apply this over here. Let's apply this over here. Okay. Now this is the point. Yes, Anup, you are absolutely right. Work done 0 hoga. Yes, you are absolutely right. Now let's talk about this point. Okay? Now this point is being moved up. Okay? So there will be some tension. Now remember, I am interested in the work done by tension, not the work done by external agent. External agent, I'm not interested. I'm interested in work done by tension. Okay? Now when I'm pulling this string up, the tension on my hand, imagine I'm pulling this string up. So the tension on my hand is going to be where? It is going to be down. So on this point, the tension T is over here. Do you agree? On this point, the tension is going to act downwards. Okay? On this pulley, the tension is going to act upwards. On this pulley, the tension is going to act upwards. On this point, which is attached here, tension is going to act downwards. Correct? ठीक है? T. अब क्या बचा? Now on this pulley, the tension is going to be 2T. Do you agree? Because pulley is massless. अगर पुली massless है तो क्या होगा? Force is equal to mass times the acceleration. Is the acceleration of the pulley 0? No. The pulley is going to accelerate upwards. Is the acceleration of the pulley going to be 0? No. The mass of the pulley is 0. Hence, the force is going to be 0. So, whenever you have a massless pulley, the net force on it has to be equal to 0. So, if T and T are acting upwards, 2T is going to act downwards. So, on this block, 2T is going to act upwards. Okay? Yes. And we are obviously assuming that the tension is, the string is massless. So tension everywhere is going to be the same. And because the pulley is also massless, the net force on the pulley is also going to be 0. सो हमने खेल लिया ना टीटी, टी 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 टू टी टू टी, वी हैव प्लेड दिस, ठीक है, वी आर डन विद दिस गेम. नाउ थिंक दैट ऑन व्हाट पॉइंट्स यू हैव टू कैलकुलेट द वर्क डन. Do you have to calculate the work done on the pulley? Do you have to calculate the work done on the pulley? No, because on the pulley the net force is 0. So even if there is displacement, there is going to be no work done. So you don't have to calculate the work done on the pulley. चाहे fixed pulley हो, चाहे movable pulley हो, you don't have to calculate the work done on the pulley. Correct? Now on this point, do you have to calculate the work done by the tension? Obviously not, because this point is fixed. No displacement, no work. तो बचा कितना? बचा तो दो ही टेंशन. There is one tension over here and there is one tension over here. So if I assume that this point moves up by T1 and I assume that this point moves up by x2, then what will be the work done? The work done by T will be minus Tx1. देखो ध्यान से, the tension is acting down. Tension on that point is acting down. And x1 is up, so the work done is going to be minus Tx1. Now here 2t is up and x2 is also up, so this will be plus 2t x2 and this will be equal to 0. तो यहां से कितना आ जाएगा? यहां से आ जाएगा x1 is equal to 2x2 and we have already seen that relationship. Correct? So either you can use, so there are three methods you can use. Either you can use the constraint relationship, either you can use the common sense method, or you can use the work done by the concept of virtual work. So there are three methods you can use. अलग अलग जगह अलग अलग चीज बेटर होती है, but if you trust me, most of the time concept of virtual work is going to work the best, because most of the time ideal situations are given. If ideal situations are not given, concept of virtual work will not work. ये ध्यान में रखना. ये मत बोलना कि सर ने बोल दिया बेस्ट मेथड हर जगह लगा दो. ना 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 ना, हर मेथड का एक लिमिटेशन होता है. सो द कॉन्सेप्ट ऑफ वर्चुअल वर्क इज गोइंग टू वर्क बेस्ट, और इट इज गोइंग टू वर्क व्हेन आइडियल कंडीशंस आर गिवन. When there is deviation from ideal condition, go back to the basic things. Go back to the constraint relationship or the common sense method. The constraint relationship and the common sense method are going to work everywhere, irrespective of the given situation, just because the length of the string is constant. ठीक है? But most of the times we encounter problems, we encounter ideal situations. So in ideal situations, we should use the concept of virtual work. Is that correct? Arpit बोल रहा है which is the best method. I just explained Arpit कि what is the best method. The best method is concept of virtual work given ideal conditions are given. Otherwise use the other methods. And I am going to string massless cannot be stretched, pulley massless and frictionless. Yes, spot on Swastika. So now we are going to do questions और इससे और clear हो जाएगा. ठीक है? This will make things much more clear. ठीक है? So we are going to use both the methods. ठीक है? तो टेंशन नहीं लेना है, टेंशन खेलना है, टीटी खेलना है, but टेंशन लेना नहीं है. ओके? चलो. So now we are going to solve a few questions. Prakhar is asking, sir, if rope has mass, then virtual method fails. Yes, Prakhar. अगर rope has a mass, then the tension is not going to be the same. And if the tension is not going to be the same, the tension is not going to get cancelled. तो वहां पे ये method fail हो जाएगा. You're right. Rope को अगर mass दे दिया है, then stick with the constraint method or the common sense method. All right? चलो. Alright, chalo, let's solve this question. Now what is happening? You see what is the situation? Now this point is being pulled down with the velocity v. We have to find out the velocity u. There are two different situations. We have to find out the velocity u. We have to find out the velocity of the block u. Tension तो लेना ही पड़ेगा ना सर? ना ना अर्पित, टेंशन लेने नहीं है, टेंशन से खेलना है. We have to play with tension. We don't have to take tension. Okay, there is a difference. चलो, let's get started. So I'm going to solve it by both methods. ठीक है? आपकी श्रद्धा, आपको जो मेथड पसंद आए आप वो मेथड यूज कर लो, जिसकी जैसी श्रद्धा. ठीक है? But if you ask me personally, I will say ideal conditions go for concept of virtual work. चलो, but what we are going to do here is we are going to first use constraint. All right? Ready? चलो, let's start. Okay. Now this is divided into how many segments? This is divided into 3 segments. ध्यान दो. These are divided into 3 segments. पहला segment है ये से ये, दूसरा segment है यहां से लेके यहां, और तीसरा सेगमेंट है यहां से लेके यहां, ठीक है? इज दैट करेक्ट? इज दिस करेक्ट? प्रखर इज सेइंग 2TV इज इक्वल टू 2U cos थीटा टी. आई थिंक प्रखर थोड़ी गड़बड़ हो गई है. आई हैव टू चेक, आई हैव टू चेक, ठीक है? थोड़ी आई थिंक इस केस में आई थिंक थोड़ी गड़बड़ हो गई है. विल चेक, डोंट वरी, ठीक है? सो फर्स्ट ऑफ ऑल देयर आर 3 सेगमेंट्स. डू यू अग्री और नॉट? यू अग्री. ओके, अग्री कैसे नहीं करोगे, करना ही पड़ेगा, ठीक है? ओके, हाँ अभी आई थिंक यू आर राइट. अरे 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 भाई एक आंसर दो ना. हियर TV इज इक्वल टू 2T cos, हाँ करेक्ट. प्रखर यू आर करेक्ट. when you are writing TV is equal to 2T cos theta U, I think you are right there, ठीक है? but hold on, स्वास्तिका V cos theta नहीं होगा. सुनो ध्यान से सुनो. okay, so the relationship we were using, तो हमने क्या बोल रहा कि summation of Ti xi is equal to 0. तो हम लोग अगर इसको एक बार डिफरेंशिएट कर दें तो ऐसा बोल सकते हैं ना कि summation of Ti Vi is equal to 0. करेक्ट और नॉट? करेक्ट है ना? तो डायरेक्टली वी कैन प्ले विद वेलोसिटी और डायरेक्टली वी कैन प्ले विद एक्सेलरेशन, ठीक है? ये करने की जरूरत नहीं है कि फर्स्ट यू फाइंड द रिलेशनशिप इन एक्स देन डिफरेंशिएट फाइंड द रिलेशनशिप इन वी. वी ऑलरेडी नो दोज रिलेशनशिप्स आर द सेम, ठीक है? ओके, चलो अब ध्यान से सुनो. नाउ दिस ब्लॉक इज गोइंग अप बाय यू. व्हाट इज अज्यूम? दिस ब्लॉक इज गोइंग अप बाय यू. सो दिस पॉइंट ऑफ द पुली इज ऑल्सो गोइंग टू गो अप बाय यू, करेक्ट? The block is attached to the pulley, so if the block is going up at the speed of u, the pulley is also going to go up with the speed of u. And we know that the points which are fixed to the movable pulley are also going to go up by u. Agreed or not? The points which are fixed to the pulley are also going to go up by u. ये मैंने बताया था ना? The points which are attached to a movable pulley, the points which are attached to a movable pulley, they will have the same displacement as the center of the pulley, correct? Okay, so now what is going to happen? Now let's talk about this segment. कौन सा segment? ध्यान से देखो. We are talking about this segment. Okay, now here this point is fixed, so what is the change in length? 0. This point, what is the velocity? The velocity is u upwards. But what is the velocity along the string? We have to be concerned with that, na? Velocity jo bhi ho, I don't care. I want the velocity along the string. So velocity along the string is how much? It is u cos theta. And where it is directed? It is directed towards the center of the string. So minus u cos theta. है कि नहीं? Is this correct? तो segment 1 का काम done. Okay, segment 1 का काम done. Now segment 2. I am talking about this point. This point has a velocity u up, but what is the component of the velocity along the string? It is u cos theta. Where is it going? It is going towards the center of the segment. So minus u cos theta. Now I am talking about this point. This point is fixed to a fixed pulley. It is going to do nothing. Now I am talking about the third segment. I am talking about this point. This point is fixed to a fixed pulley, is attached to a fixed pulley. तो ये कितना हो जाएगा? 0. And now I am talking about this point. This point has a velocity what? This point has a velocity v, which is going away from the center of the segment. मतलब plus v. Now I have written the constraint relationship for the entire string. Now I can say this is equal to 0. Which means u will be equal to v divided by 2 cos theta. Is this clear or not? सखी बोल रही है सर फ्री बॉडी डायग्राम ड्रॉ करके दिखाओ, विल बी मोर कन्वीनियंट. सखी यहां फोर्सेस की बात ही नहीं कर रहे हैं, तो फ्री बॉडी डायग्राम का क्या काम है? यहां तो कंस्ट्रेंट रिलेशनशिप का काम है. प्रखर इज सेइंग v upon 2 cos theta. Yes, absolutely. All right guys, चलो if you understood this, quickly give me a thumbs up. ये समझ में आया या नहीं आया? All right, so we have written the constraint relationship for each segment of the string. We have written the change in length for each segment of the string, added them, that gives us the change in the length of the string, and we have made it equal to 0. यानी कि u कितना आ गया? u आ गया v upon 2 cos theta. आई बात समझ में? इज दिस क्लियर गाइस? एवरीवन, इज दिस क्लियर? स्वास्तिका, अर्पित, इज दिस क्लियर? चलो फटाफट गिव मी अ थम्स अप इफ दिस इज क्लियर. परफेक्ट, परफेक्ट. ठीक है, चलो. नाउ वी आर गोइंग टू सॉल्व दिस क्वेश्चन विद द कॉन्सेप्ट ऑफ वर्चुअल वर्क ऑल्सो. ठीक है, रेडी टू प्ले टीटी? चलो लेट्स प्ले टीटी. एंड नाउ वी आर स्मार्ट इनफ टू नो कि कहां टीटी खेलना है. हर जगह टी लिख के गंदा नहीं कर देना है डायग्राम. ठीक है, सो फर्स्ट ऑफ ऑल लेट्स टॉक अबाउट दिस पॉइंट. दिस पॉइंट इज मूविंग, तो यहां पे टेंशन कितना हो जाएगा? यहां पे टेंशन टी हो जाएगा. ओके, यहां पे टेंशन कितना हो जाएगा? टी हो जाएगा. नाउ डू आई नीड टू वरी अबाउट, ठीक है चलो, यहां पे टेंशन कितना हो जाएगा? टी हो जाएगा. यहां पे टेंशन कितना हो जाएगा? टी हो जाएगा. यहां पे टेंशन कितना हो जाएगा? बताओ. What will be the tension over here? Can anyone tell me? Can anyone tell me what will be the tension there? बताओ भाई. This is a movable pulley which is frictionless, massless, everything. Ideal pulley. Now the tension is on the left string is T, on the right string is T. On the downward string, what will be the tension? बताओ भाई, कोई मेरे को फटाफट बताओ. अनु बोल रहा है टूटी. टूटी, आर यू गा इज सेइंग टूटी. है, टूटी करने से ना किस्मत हो जाएगी फूटी. यू डोंट सोच के बताओ. देखो व्हाट इज द कॉन्सेप्ट. कॉन्सेप्ट भूल रहे हो ना. टी टी टूटी, टूटी टूटी 40, यही करते आ रहे हैं. कॉन्सेप्ट भूल जा रहे हो. कॉन्सेप्ट क्या है? हाँ, अनूप ने अब सही बोला. हाँ जी अनूप, अभी सही बोला. अर्पित, फिर सोच के बोलो. देखो, what is the concept? The concept is that if a object is massless, the force on it will be 0. तो टेंशन ऊपर नहीं लग रहा है ना, टेंशन टेढ़ा लग रहा है. तो we'll have to take the component of tension ना. So t cos theta and t cos theta will become 2t cos theta, and t sin theta and t sin theta will get cancelled. मतलब what is the net upward force? The net upward force is 2t cos theta. तो यहां कितना फोर्स लगेगा? यहां पे 2t cos theta लगेगा. यानी कि इस ब्लॉक के ऊपर, ऑन दिस ब्लॉक, ठीक है, आई एम जस्ट मॉडिफाइंग द डायग्राम अ बिट, या चलो नहीं करता हूं. ऑन दिस ब्लॉक द टेंशन इज गोइंग टू बी 2t cos theta upwards. Do you agree? On this block the tension is going to be 2t cos theta upwards. Do you agree or not? ठीक है. So on the pulley downwards the tension is 2t cos theta. So on the block tension 2t cos theta is going to act upwards. Okay. Now we assume that the velocity is u upwards. The velocity of the block is u upwards. So we only have to calculate the work done on what? We only have to calculate work done on the point which is moving. We only have to calculate the work done on the point which is moving, and the point which is, and the points which are fixed, or the movable pulley. The movable pulley has no net force. So we don't have to worry about the points which are fixed and the points which are or the movable pulley. So all we have to do is find out the tension between, find out the work done on which 2 points. चलो फटाफट बताओ. We have to find out the work done on which 2 points. अरे यार मेरे वैक्यूम को क्या हो जा रहा है? Some loose connection. Just a second guys. तुम लोग आंसर बताओ फटाफट. Give me the equation. ठीक है, while I am fixing this, quickly give me the equation. Quickly give me the equation. So work done by tension we only have to calculate on 2 points. One is this. What is this work done? This work done is going to be minus TV. And work done नहीं है, it becomes power. लेकिन you understand कि टेंशन इंटू डिस्प्लेसमेंट लिखेंगे फिर डिफरेंशिएट करेंगे, इसलिए डायरेक्ट यही लिख दो ना. ठीक है. सो व्हाट इज दिस गोइंग टू बिकम? दिस इज गोइंग टू बिकम माइनस टीवी. डू यू अग्री? दिस इज गोइंग टू बिकम माइनस टीवी. एंड व्हाट इज दिस गोइंग टू बी? दिस इज गोइंग टू बी plus 2t cos theta into u. The work done is going to be plus 2t cos theta into u, because 2t cos theta is up, u is also up. In this case tension was up, velocity was down. So minus tv is equal to 2t cos theta, u is equal to 0. This gives me u is equal to v upon 2 cos theta. Is that right or not? Chalo, is this clear guys? Is this absolutely clear? Give me a thumbs up quickly. Give me a yes if this is clear. Any problem here? All right. Is this clear? Chalo, quickly give me a thumbs up. Now let's look at this question. Okay, it's a similar question. Now how do you want to solve it? Do you want to solve it using concept of virtual work or do you want to solve it by constraint method? दोनों से solve कर लेते हैं. ठीक है, quickly करते हैं, but let's do it quickly. So this is the first segment, this is the second segment, this is the third segment, and this is the fourth segment. So let's quickly do it. ठीक है, I'm talking about this point. What I'm going to write is plus V. I'm talking about this point. This is 0. I'm talking about this point. 0. I'm talking about this point. This point will be u is like this. So this is going to be u cos theta. So I'm going to write minus u cos theta. Now I'm talking about this point. U is up. So this is going to be u cos theta. And I'm going to write minus u cos theta. I'm talking about this point. This is 0. I'm talking about this point. This is 0. I'm talking about this point. This is plus v. This is equal to 0. यानी कि यहां से कितना आ जाएगा? यहां से आ जाएगा 2v is equal to 2u cos theta. मतलब u is equal to v upon cos theta. Clear है? Yes, Anup. Very good. Very good. Very good. Very good. Clear? कोई तकलीफ? चलो, perfect. So understood? Using the constraint method, and I am writing everything, but as you practice it, you just have to write, or you can do it orally. When you practice this a little bit, you can do these questions orally. कुछ करने की जरूरत नहीं है. You don't even have to write. ऐसे आंख से देखोगे और बोल दोगे. Correct? So u will be equal to v upon cos theta. Concept of virtual work से भी कर लें क्या? कर लेते हैं फटाफट. So tension यहाँ पे आएगा t. Tension यहाँ पे आएगा t, because the same string. टेंशन यहां पे कितना आएगा? यहां पे आएगा 2t cos theta. We know that already. So we only have to calculate the work done on these 3 points. बाकी सब क्या है? बाकी सब या तो fixed point है या pulley है. Pulley is massless, no work done. Okay. I'm talking about this. What is this going to be? This is going to be minus TV. I'm talking about this. What is this going to be? This is going to be plus 2t cos theta into u. I'm talking about this. What is this going to be? Minus TV. This is equal to 0. This is going to give you u is equal to v upon cos theta, and you are sorted. Correct? So with practice, you will be able to do this in 10 seconds, maybe 10 seconds, 15 seconds. So with practice, you can find these relationship between accelerations in a jiffy. ठीक है, कॉन्सेप्ट ऑफ वर्चुअल वर्क लगाना है या फिर आपको कॉमन सेंस मेथड लगाना है या आपको कंस्ट्रेंट मेथड लगाना है, जो भी आपको लगाना है तुरंत हो जाएगा. ठीक है, इज दिस क्लियर गाइस? इज दिस क्लियर? एब्सोल्युटली क्लियर? एनी प्रॉब्लम? अभी जैन, हेलो सर. अभी जैन, अभी क्यों आ रहे हो यार? अभी तो सेशन एंड पे है. कौन सा टॉपिक चल रहा है? वी आर टॉकिंग अबाउट कंस्ट्रेंट मोशन. ठीक है, वेज एंड पुली कंस्ट्रेंट. आप क्या ही समझाना चाहते हैं? हम समझाना चाहते हैं कंस्ट्रेंट. द पॉइंट इज आप क्या समझना चाहते हैं. ऑलराइट, चलो गाइस, लेट्स सॉल्व अ क्वेश्चन. एक और क्वेश्चन फटाफट सॉल्व करते हैं. चलो, अब आ गया थोड़ा कॉम्प्लिकेटेड सिचुएशन. थोड़ा सा कॉम्प्लिकेटेड सिचुएशन आ गया. ओके, इसमें यू कैन सॉल्व इट यूजिंग कंस्ट्रेंट्स. You can solve it using common sense method also. ठीक है, you can solve it using concept of virtual work also. ठीक है, which one do you want to solve? अनूप बोल रहा है सर मेरा स्कूल होता है, मैं आपका क्लास लाइव अटेंड नहीं कर पाता हूं. कोई बात नहीं अनूप, if you are not able to attend it, if you are not able to attend the class live, तो रिकॉर्डेड सेशन भी तुम देख सकते हो. ठीक है, चलो, how do you want to solve it? Quickly guys, how do you want to solve it? खेलें, टीटी खेलें. So ideal conditions are given. Ideal conditions are given. Common sense, ठीक है अर्पित, we can solve it using common sense also, but we have to see ना कि best method क्या लगेगा. ठीक है, so if we have ideal conditions, तो virtual work use करते हैं ना. ये संदीप सही बोल रहा है. So what do we need to do is we need to use concept of virtual work because ideal conditions are given. आइडल कंडीशंस नहीं होगा तो अपने को थोड़ा टेंशन होता है. तो लेट्स प्ले टीटी. रेडी फॉर प्लेइंग टीटी? चलो लेट्स स्टार्ट टीटी. तो ये टी, तो ये भी टी, तो ये भी टी, तो ये 2t, तो ये भी t. So I am writing tension only where it is, I am writing tension only where it is relevant. बाकी जगह मेरे को टेंशन लिखने की जरूरत क्या है? बाकी जगह where we have a fixed pulley, why do we want tension? जरूरत ही नहीं है. Where we have a movable pulley, we only want to find tension so that we can find tension on the block. Where there is fixed pulley, I don't want to find the tension. ठीक है? So what are the only two places where we have to find the work done? One place is this and the next place is this. That's all. ठीक है? चलो. So this car is moving with a speed v. So we can assume that this block is moving up with a speed u. ठीक है? Car is moving with a speed v. Block is moving up with a speed u. So what is the work done on the block? Now there is a tension 2t upwards. So this is going to become plus t 2t into u. Correct? There's a tension which is acting upwards 2t. And the displacement is also up, so 2t into u. Now let's find the work done for this car. Now here we have to be a little careful. Okay? Here we have to be a little careful. यहाँ पे one tension is like this, one tension is like this. So either what you can do is you can calculate the tension by both, or you can calculate the work done by the net force. So what I'm going to do is I'm going to resolve this as t cos theta and t sin theta. Now you can forget about this tension. So what do we have? In the horizontal direction we have t plus t cos theta. In the vertical direction we have t sin theta. The displacement is horizontal. If the displacement is horizontal, then t sin theta is not going to do any work. All the work is going to be done by t plus t cos theta. Now get this. T plus t cos theta is in the opposite direction. Velocity is in the opposite direction. Correct? Which means this is going to be minus t into 1 plus cos theta multiplied by v. Do you agree? How we are calculating the work done. Okay? Which means that the tension is in the opposite direction to velocity, so the work done is going to be negative. Hence I have put a negative sign. So this is going to be equal to 0. So this t and this t is gone. So 2u is equal to 1 plus cos theta. Cos 60 degree कितना हो जाएगा? 1 by 2. So this becomes 3 by 2v. यानी कि यहाँ से u आ जाएगा 3 upon 4v. Is that correct? Clear? Now tell me honestly, before knowing concept of virtual work के बिना, if you had to solve this question, तो डर लग जाता है कि नहीं? Honestly बताओ. ठीक है? If you had to solve this question without concept of virtual work, तुम्हारे पसीने छूट जाते है कि नहीं? Even though you can solve it, now you can solve it, but what will happen? ज़्यादा टाइम लगेगा. ठीक है? You can still solve it. You can solve it using constraint method, but क्या होगा? थोड़ा ज़्यादा टाइम लगेगा. ठीक है? But after this, you are not going to face any problem with any kind of question. That's my assurance. ठीक है? Where you have non-ideal conditions, you can still use constraint method or the common sense method. ठीक है? So nothing to worry over here. This is covered. Correct? चलो. So done. This question is done. अब थोड़ा सा टाइम अपने पास बचा है, फटाफट वेज कंस्ट्रेंट की बात कर लेते हैं. ठीक है? वेज कंस्ट्रेंट की बात कर लेते हैं. नाउ यू कैन गो अहेड, सॉल्व मोर प्रॉब्लम्स ऑन कंस्ट्रेंट. मैं बता रहा हूं प्रॉब्लम अब नहीं आएगा. ठीक है? ट्राई इट, you will not face a lot of problems. Okay, now let's talk about wedge constraint. Wedge constraint का मतलब क्या होता है? First of all, the condition is the object should be rigid and the block and wedge are always in contact. Now the block can have velocity in any direction, the wedge can have velocity in any direction, but if the block and the wedge are in contact, तो we can apply wedge constraint. Is this clear? तो simple फंडा क्या है? सिंपल फंडा ये है कि when the block and the wedge are in contact, the velocity of separation perpendicular to the common surface will be equal to 0. लिख देता हूं इस बात को. Velocity of separation perpendicular to the surface of contact will be 0. ये बात समझ में आ रही है? Now this surface. This is the surface of contact. Now if they are not separating, ठीक है, अलग अलग नहीं हो रहे हैं, Swastika is saying basically block will not move perpendicular to the wedge. कोई गारंटी नहीं है. No Swastika, कोई गारंटी नहीं है block will move perpendicular to the wedge. In fact, if all the surfaces are frictionless, it is not going to move perpendicular to the wedge. ठीक है, but एक बात की गारंटी है, the relative velocity along the surface of contact will be zero. है कि नहीं? The velocity of separation perpendicular to the surface of contact will be zero. If there was relative velocity perpendicular to the surface of contact, then ये अलग हो जाना चाहिए था ना. If there is velocity perpendicular to the surface of contact, then there should become separation between the surfaces. But if we are saying that the block and the wedge are always in contact, then the relative velocity perpendicular to the common surface is going to be zero. Is this clear? Yes, Arpit, always. Given the condition that the block is always in contact with the wedge. The block is always in contact with the wedge. तो block किधर भी जाए, wedge किधर भी जाए दुनिया में, I don't care, as long as the block is in contact with the wedge, the relative velocity the relative velocity perpendicular to the common surface is going to be zero. ठीक है? तो let's say this block has a velocity v2 like this. So the component which is going to be parallel to the wedge is v2 sin alpha. The component which is perpendicular to the common surface is v2 cos alpha. Let's say the wedge is going with the velocity v1. So the component of the velocity of the wedge which is perpendicular to the common surface is v1 cos theta. So we can say that v2 cos alpha will be equal to v1 sin theta. Is this clear, guys? v2 cos alpha will be equal to v1 sin theta. आई बात समझ में? This is the wedge constraint. Is this clear? चलो, if this is clear, let's quickly solve a question. So now we have guides. Guides मतलब small m can only move up or down. ठीक है, उसको constrain कर दिया. So small m can move only up or down. Correct? So if small m comes down, capital M is going to go to the left. So what I need to do is I need to find the relationship between the displacements of small m and capital M. Alright, I need to find the relationship between the displacements of small m and capital M. Let's say small m gets displaced by a distance small x. And capital M gets displaced by a distance of capital X. ठीक है? I need to find out the relationship between small x and capital X. Now you guys tell me how to find the relationship. Okay. Now the concept is very simple. Let's talk about capital X. This is capital X का displacement. This angle is theta, which means that the displacement of capital X or displacement of capital M perpendicular to the surface of contact is going to be how much? It is going to be x sine theta. Do you agree or not? The displacement of the wedge perpendicular to the contact surface is going to be x sine theta. Agreed or not? Agreed? करना ही पड़ेगा यार. Agree कैसे नहीं करोगे? Agree तो करना ही पड़ेगा. All right. Next. Now the component of small x. अब ये बताइए the component of small x, ये कितना हो जाएगा? If this is theta, this is 90 minus theta, this is theta. So the component of small x perpendicular to the surface of contact is x cos theta. यानी कि I can say that capital X sin theta should be equal to small x cos theta, which means small x is equal to capital X tan theta. Do you agree? So we can say that small v is equal to capital V tan theta. So we can also say that small a is equal to capital A tan theta, and hence you have found the relationship. Is this clear? Right? So what do we have to do? We have to say that the displacements perpendicular to the common surface are going to be equal, or the relative displacement perpendicular to the common surface is going to be 0. Is this clear or not? Guys, is this clear? Absolutely clear? Sir, is there no scope in civil branch from NIT Rourkela? Monty यार, यहाँ पे हम क्या कर रहे हैं? यहाँ पे पढ़ाई कर रहे हैं ना? So we are talking about that. There's a different forum you can ask these questions on. ठीक है? यहाँ पे we are only talking about our subject. ठीक है? चलो. Now this I am giving you as homework. This is a beautiful question which is a combination of relative motion and wedge constraint. This is a beautiful question. This is an amalgamation. This is a marriage of relative motion and wedge constraint. Okay? So note this question down and you can put your answer in the comment section. Okay? I'll check. And if you want hints, if you want more suggestions, I'll give you suggestions over there. But please do try this question. This is a beautiful question. Alright? Chalo. With that said, we are going to wrap up this session over here. And I'm going to come again at 5 o'clock. And this time I'm going to bring something else. Okay? I'm going to bring percentile booster session. So what I'm going to do is, I'm going to I have selected some very high ROI topics. A very high ROI topics means effort come, result बहुत ज़्यादा. ठीक है? So I'm going to come with such topics and we are going to solve some previous year questions, some other questions so that I can revise those topics in a very small amount of time. क्योंकि वो topics में ज़्यादा मेहनत की ज़रूरत नहीं है. ठीक है? Little bit of understanding you need and you're going to solve questions very easily. So those are very high ROI topics. Those are the topics which are going to give you the maximum marks. Those are the topics that are going to give you the rank. Okay? So do come at 5 o'clock again. Yes, today 5 o'clock we are going to do thermodynamics. We are going to do some very good questions on thermodynamics and I'll try to revise the entire thermodynamics for you in that session. ठीक है? Thermodynamics, as I said, is a very high ROI topic. बहुत आसान टॉपिक है, मेहनत कम, रिजल्ट बहुत ज्यादा. ठीक है? So see you guys again at 5 o'clock. Till then, keep practicing, keep getting better, and remember, you guys are rankers. Thank you so much for watching. See you soon.